Yeah, anytime I start going with class and I didn't hit record, just, yeah, shout out, let me know. I apologize. I'm gonna kind of review back through it real quick, just so we have it recorded. So on the division, again, what I want to do, if it's 2, base 6 divided into 4, 2, 5, 4, 3, base 6, take the divisor, multiply it by every digit of that base, in this case, base 6. And find all those products in base 6, because we don't know them on top of our head. So then once I have this made out, I use it for reference to do the division. So I can look and say, okay, that's going to only go one time. And then subtract in that base, in this case, base 6. So 2 minus 2 is 0, 4 minus 2 is 2. Bring down the next digit like normal. Now, then subtract again in base 6. And so here we have the bar. Here, 5 minus 4 is 1. And here I've got a bar. So what I do is I go to the next digit, reduce it by 1. And what I'm doing is bringing over a group of, in this case, 6. It's bringing over a group of whatever the base is. And 6 minus 5 is then 1, because you want 6 plus 0 is 6. Bring down the next digit. And then I look at it and say, well, 1, 4. So it's got to go 3 times. And so put the 3 here, put here, again, subtract, I got 4, 3, which then to the table would only go 1 time. And then my remainder, and by something we call division algorithm, the remainder always has to be what? Strictly less than what you're dividing by, everything. Okay, so that was number 6. On number 2, we were adding in base 16. Now, for addition in another base, what we do is we add each sum of that addition. And usually you can do it mentally. We were really able to do it mentally here. Add it in base 10 and then convert to that base. Now, since it's base 16, I wrote out this just so I made sure I was using the right base 10 number correlating to each base 16. So here I went 13 plus 14 is what? 27. And that's right. Then I convert 27 in base 10 to base 16. And so it takes one group of 16. So that's in the 16 to the first place, plus how many ones, or basically the remainder of that division, which would be 11. So that's why it's B. And so it's 1B. So B here, carry the 1, and then add likewise to the problem. Okay. All right. Sorry about that. So that's 2 of the 6 problems. There's 4 others. So any others you want to see? Number 5. That always gets asked. So if there's one, sometimes there's only one ever asked, and that's always it. That is the multiplication in base what? 16. Okay. So here we go. Here. I think I remember this one off memory. I think A, B, C, D. Yeah. What is the B being base 16? All right. And just for the record, this one I owe every class before you has to do this one. So I've already got this here. So multiplication, which is just repeated addition, what it basically means is we're gonna do it by the same format, that is, whatever the base is, we're gonna find each of these individual products in what base, what, 16? Or multiply, I'm sorry, multiply them in base 10, then convert it to what base, what, 16. Now, this one, you probably do want to have a what calculator for the arithmetic, because the numbers are gonna be a little bit bigger here. Because when you go F times D, that's gonna be 15 times what, 13. So I'll just go ahead, 15 times 13. And that gives me 195. So now I need to figure out how many groups of 16 are in 195, which basically means divide 195 by 16. So 195 divided by 16 is 12. So what that tells me is there are 12, which means what? E groups of what? 16. And then I need to know how many ones were left over. When I say ones, that's really not correct. How many 16 to the zeros? Which I guess is one. But so basically what I can do is go 12 times 16, which is 192, and take that away from 195, which will be what? 3. So it's C3. And yes, it starts sounding like you're playing bingo. So when you're working with base 16. So 3 and carry a what? A C. And I do love when folks just walk by randomly and, you know, just catch something I'm saying in here with no context of what we're doing. It freaks people out. And there is one other thing we're going to look at that's even better than this before we leave this semester. How crazy can arithmetic get? So I always try to catch somebody walking down the hallway when I say this, right when they're at the door, and I go 10 plus 4 is 2. I can prove it. I can prove it. 10 plus 4 is 2. That's, they're walking by. She's like her. She's walking by. She's like, 10 plus 4 is 2. That was actually Dr. Spivey. So, if you look around the room, you'll you'll understand what I'm saying. 10 plus 4 is 2. All right, let me direct you a little bit more. Look behind you, directly behind you. 10 plus 4 is 2.
4 hours.
Clock arithmetic. 10 plus 4 is 2. But that actually expands, that is one example of something called modular arithmetic. We'll talk about it later, but yeah. 10 plus 4 is 2, and I can prove it. All right, so back to here. So we've now got to add what? Or multiply. F times what? C, and then add C. So I'm going to go 15 times what? 12 plus 12. And that is going to render 192. So here now you can look at it and hopefully see that's going to be C groups of 16 plus what? 0. Or it's C0. So 0 and carry the what? C. And we'll continue on. Now it's going to be 15 times 11 and then plus 12. Now that gives me 177. So I will divide that by 16, see how many groups of 16 will go, and it's going to go 11. So that will be what? B. Now I will go 11 times 16, which is 176. So that tells me that the remainder was 1. So it's B1. So one last one here. It's going to be 15 times 10, which is 150, plus 11, which is what, 161. And then 161 divided by 16 will go what? 10 times with the remainder of what? 1. So that will be A root of 16 plus 1. All right. One row complete. And then per normal, we will put a placeholder. So we got our placeholder.
Mr. Cunningham.
Yes.
Okay, so the one where you did 15 times 11,
Yes.
you put 177. Is it not 165?
Okay, so 15 times 11 is 165.
Plus the.
But the 15 times 11 was where I had multiplied the F times B, right?
Okay,
That was 15 times 11, but I also had to add a what? A 12.
okay,
And
okay.
so that's where I got the 177. We good?
Yeah, I'm good. Sorry.
No apologize. If this was easy, everybody'd be here doing this. All right. Okay. Now. My mother's on my mind right now. So my mom's an artist, and which you all should at this point find that highly ironic. I mean, she can sculpt, paint, draw. Right now, her thing is watercolors, and then she just doesn't. I can't even imagine doing something. She's like, oh, it's so easy. Guess what her most, I mean, hate with an H, capital H, subject is.
Probably not art.
Not art. Nah, she would rather go jump off the Parkersburg Bridge before take a math class.
Or say on the floor, like you said. Not go to the doctor.
Yep, so, that's whatever. Yeah, not into the math. So we never quite figured out how that all worked out, but anyway. Okay, so now we're multiplying by what? E. So it's gonna be 14, and then down the line. So first one is 4E times D, so this is gonna be 14 times what? 13. 14 times 13 is 182. So we will divide that by 16. It's going to go 11 times. That's B. B groups 16. And then we will go 11 times 16. Oops. 11 times 16 is 176. So that would leave me a remainder of 6. B6. So a 6. Area B. I just write it right above here. I think that's the one working. All right, now we're going to be going 14 times 12. And then plus what I carried over, which is 11. Which is 179. Now, if so, I'll go ahead and divide it out. So 179 divided by 16 goes 11 times. So it's what D groups of which is 176. So that is what 3. Now, again, I could have used this one. If 177 is B1, then 179 has to be B3. So 3 carry a B. And now we're going 14 times 11 plus 11. All right, that gives me 165. Jump over here on this one. 165. Okay, so that has got to be goes 10 times. And the remainder has got to be 5. 85. So 5, carry, and A. Now, last product, 14 times 10 is 140. Plus 10 would be 150. All right. Now, at least we'll finally get a leading digit other than a letter. That's going to go 9 times. And then 9 times 16 is 144. So that leaves me a remainder of 6. 9, 6, 16. So 6 and a what? 9. Now, just when you thought this bad dream was over, you gotta what? Now you gotta add them up in base what? 16. So here we go. That would now, turns out that addition's not too bad here. Because you're gonna add in base 10 and you're always gonna get a digit that's within base 16. So you're not gonna actually have to convert until you get about here. So 3 plus 0 is 3. 0 plus 6 is 6. 1 plus 3 is 4. 1 plus 5 is what? 6. Now, and this very problem I've had on test before. Not always, but I've had them on test before. And if there's one place that gets messed up, I've seen people like get everything right. And right here, they go, okay, 10 plus 6 is what? 16, and they write a 6 and a 1. It's what? 1 and a what? 0. You get 16, then in base 16, that is 1, 0. Good. 16 has got to be in base, so that's a base 10 number. 116 plus what? No ones. So that is simply 0. And then 1 plus 9, I've also seen people write 1, 0 here, 10. But that's 10, and 10 in base 16 is what? A. Now we're done. Good. If you can do that one, you can add and multiply any base, even base 2. And I never threw one of those at you. That base 2, that you can imagine just using zeros and ones, you can get right.
So for questions like that, if it's a different base, do you just put a different number in multiplying?
Not sure I quite.
So if it was like base 8,
Okay.
instead of like the C 16 plus 3, it would be like C 8 plus 3.
Okay, so if it was base 8, then you would just be using digits 0, 1, 2, 3, 4, 5, 6, and what? 7. The reason we're having to use these capital letters is we ran out of digits. Since they're in base 16, you have to have, for our positional place value system, you have to have 16 digits. In base 8, you have to have 8 digits. Now, the process would be the same. You would multiply in base 10, get that number, and then be dividing by 8 to write it, but you would never have to use those capital letters. Okay. Basically, any base bigger than 10, like you theoretically you could use base 11, but it would be 0 through 9, and then just A. Base 12 would have A and B. Base 13. The reason we're looking at base 16 is actually has practical applications. So, okay. Any other questions? Okay. Nope. Not good. All right, hold on to those. If you're going to turn them in, I'll get them here before we leave. If you want to go rework anything, I said I will take them on Monday. So as well. And that goes for you guys, as far as I said, I did receive one by email. But if you want to rework those, I will take them on Monday. Or due date Monday, of course, you can send it via email anytime between now and Monday. Okay, well, looking at the clock, I had several things I thought about doing. I think we probably have time for just one. So kind of thinking about end game here, we've got, I don't have that on me. So we got next week, and then we have Thanksgiving break. So what I want to do is kind of wrap things up and have assign the test next week. Not that it's, the most fun thing to do over Thanksgiving break, but that'll give you all week on Thanksgiving break.
You don't turn the final. you know, just like that.
Yes, over what we have covered since our last unit. But we'll review next week for that. We'll get it all set. Here's what the test is going to look like and what I'll have on the test. And then you'll take it at home, just like our other exams on my math lab. And then the week after, we'll have 1 week when we come back, break, and a couple little odds and ends and review for the final, talk about what the final will look like. And then papers will be due. And so we are starting to see the light at the end of the tunnel. Okay, so what can we do today? How do we have the We're going to multiply in base 10 today. That is it, just good old base 10. So that's a little welcome relief. But what I want to look at is an alternative ways of multiplying different from our traditional algorithm here that we use. Now, I will tell you, we're going to look at 3 ways. 2 of them I don't really find that practical. I just find it kind of neat. And you can use them to talk about multiplication. The third one, I know is still used out in public schools. It's old. It's not like new math. It is old. They were using this back in, I know, 1800s. Students actually had these, this last thing that I'm thinking of, a whole set of things that like little, well, they're hard to explain without showing you what the method is. But they were able to take this big box and it would have these strips and all these numbers, and they could take this, this, and this, put them together, and then they could add diagonally, and it would be the product. That one I find very practical, and we'll talk about it obviously here in a minute. So I want to go through these 3. All right, so I'm going to make up some multiplication. And can I erase this masterpiece now? Everyone got it? Okay. All right, so I'm just making up some random 234 times 27. Now, we're not in the 1800s. We're not even in the 20th century anymore. We're in the 21st century. I can use a calculator. 234, so finding the product, not hard at all. It's 6,318, assuming I punched all these numbers up. 6,318. Okay. But how we're going to go, I want to look at some different ways to go about finding this product. Right, so this first way I'm going to do it, I want to look at these 2 here. And I want to take 1, number 1, and the larger of the 2 factors of this product. the 234 in this case. Now, this will work if you use the 27 there as opposed to the 234. It would just take you much, much longer to do it. So that's why I picked the bigger one. Now, all I'm gonna do is I'm gonna create, times there. I'm gonna put columns, going down columns here, and I'm gonna do the same thing in each column. I'm gonna ask you guys to help me out a little bit. I can handle this one. This one, I don't want to do the arithmetic in my head. I'm tired. I'm going to double every time. That means times 2 from double. So it's either 234 plus 234 or 234 times 2. What would that be double? Thank you. And then here, again,
936.
936. And have multiple people just in case. So we can double check our work as we go. All right, so this is
1872.
1872, sounds reasonable. I'm gonna double again. And double this one. I'll give you a start.
Like 3,000.
3,744.
3,744. I love it. All right. Okay, what I'd like you now to do is I want you to add at 3,744 plus 1,872 plus 468 plus 234. Add those 4 numbers up. Tell me what you.
6,300.
So if you add up this plus this, bro, what do you know? We got the product. 6,318. Now, this method. Oh boy. Somebody may Google this. You're gonna find this highly ironic. I actually double majored. Now, we're talking, I hate to say it, 30 years ago. I actually double majored undergrad math and English. So I had 2 majors and I did finish both. English actually was my first major. Math came later. That was, I didn't know I liked math until I got to college. So I always misspell the word Egypt. Egyptians actually what I'm looking for. I think it's a Y and then a G, P.
I think it's a G right after the E, I think.
Okay, that's why I knew I was-
Then a Y, yeah.
then a Y, then a P,
Yeah.
T-I-A-N. I think that's it. So Egyptian, this is referred to as the Egyptian algorithm. Referred to as Egyptian algorithm. Okay, so can you look and tell me why I may have picked out those 4 and left out the 936? But those 4 added up to be the product. Can you make an observation? Okay, I'll give you a hint. Look at the left column. See if you, not the right column, which were the numbers I picked to add up. Look at the left column. Any observation with those?
All the numbers you doubled, like 1, 2, 8, and 16 equals 27 when you add them together.
That is exactly right. She got it. Did everyone hear that? If you go 1 plus 2 plus 8 plus what? 16, you get 27. Also, these are what? Powers of 2. And we know that what? All powers of every number, every counting number can be represented by a sum of what? Sum powers of 2. And then, so that is exactly how I pick them out. That's when I know to stop. When I get a combination of this row that adds up to the other factor. Now you know why I wanted to pick a larger one here. I could have again put 27 here and done this, but then I would need a combination in this row add up to be 234. Now, there's something else you can, and why this is good to show when you are teaching multiplication to little ones for the first time, and you've gotten beyond just multiplication tables. Now you're looking at, multiplying by hand bigger and bigger numbers. We know that multiplication is what repeated what addition by definition. So you can view it this way. That's what, one group of what? 234. That's two groups of 234. That's 8 groups of 234, and that's 16 groups of 234. So why am I adding these? Because that gives me 27 groups of what? Okay. Is it practical? No, I don't think so. But it's cool. Please do now. Okay, second one. This time I'm going to write the 27 and the 234. And I'm going to go down columns again. But what I'm going to do this time, of course, I've already started a little differently. I didn't write a 1 here, I wrote 27, the other factor. I'm still going to double on the larger one. And again, this would work if I flipped it. But I want to double the larger one. What I'm going to do here with this one is cut it in half and ignore remainders. That is not double it, but divide by, not multiply by 2, but divide by 2. But if I get a remainder, of course, the remainder would have to, if I get a remainder, it's 1. Otherwise, the remainder is 0. So 27 divided by 2 goes how many times?
How do you want to round it?
So I don't want to round it. Don't round up or anything. It's 13 times, right? There is a remainder of 1, but I ignore the remainder. This I double, so I can use what we did here, so you don't have to do that. And we're going to keep doing this. So I'm going to cut this one in half. So that's going to go, what, 6 times? And then double here will be 936. All right, we're going to divide by 2 here. That is 3. 1872. And then divide, we'll go 1 time, remainder of 1, and double here. Now, we already know from doing this that it was what? This number, this number, this number. This number adds up to be our product of 6,318, correct? So we got to make an observation about these. Something about these 4 is different than this one.
Don't prime.
They are prime. Well, no, that's not prime. All right, that was a good observation. Something else. Yes. Yes. This one divided equally, which means it is what? You have 2 choices. E or O. Even number. These are all what? Odd numbers. Correct? And so how do I, if I'm using this method, how do I know which ones to pick out? Go to this column, pick out the odd ones, and then whichever ones they want correspond to here, those are the ones you add up. Make sense? This is referred to as the, and I do not know the history. I don't know how, other than I'm guessing it was invented by Russian peasants. I don't know. It is called Russian peasant method. Okay. That is the name of it, Russian peasant method. I do not know if it actually originated in Russia. I don't know. And every year I'm like, I'm going to look that up and research it. And every year I don't. So, anyway, still a mystery. But that is the name of the method. Now, you kind of hit on something about dividing evenly. Now, this isn't a full explanation of why this one works. But we go back and think about base 2. Has 2 digits, what, 0 or 1? You divide it by 2, you either get a remainder of 0 or you get a remainder of what? 1. The reason this work lies in base 2 binary. Okay, last one. This one is the practical. This is the one I like. And I do, I mean, right out here in Wood County, I have seen it. And not because I teach it here. I mean, it was there before I taught it. So, and again, it's been around for eons and eons. But you will get students who, no fault of their own, my boys, when they were in elementary school, we had triplets, so we had 3 of us. 2 boys and a girl. No offense, ladies. I thank the Lord every day it came out that way, not 2 girls and a boy. Daughter was a great, I mean, not, we didn't have 2, but yeah, she was the one that was challenging for sure. Boys, not so much, they're gamers. But they're all, you know, they're 25 now, they're all, you know, off and about and being successful and got some grandkids and whatnot. But anyway, when they were in elementary, Ivy's handwriting was good. She had a little bit of artistic ability and whatnot. The boys, it was bad. It was really bad. And they were very bright. But you know, that was just always a struggle. We worked with them and tried, but it was just who they were. And I've had students here. I remember having a teaching calculus. So I had this one student for both semesters, Calc 1, Calc 2. And his work was always A work. But when I sat down to grade tests, of course, this was, you know, paper test, not on my math lab, so grade them by hand. And I would always take his test and set it off. Because normally what I'd always do is grade it page for page, and that would keep partial credit equitable. But for him, I knew it was going to take extra time, and I sometimes literally would have a magnifying glass just to decipher. So you're going to have students like this. And so when you're teaching that normal algorithm that we use, and you're writing row after row of these products, and then you have to add them, you got to put the placeholders in for a student that really struggles. And kids also develop differently at different paces. So that hand-eye coordination. Some, you know, it just takes time before it really clicks in. What I'm saying is they don't get the numbers lined up right. They know how to multiply. They just don't get them lined up right. And so then they're adding the wrong things. And they're just getting frustrated. So it's not that we don't want them to do it, but give them another way that gives them success. Success breeds success. So here is that way where things will get lined up for them. They don't have to worry about lining things up. So we're going to multiply that same thing. But what I'm going to do is I'm going to create a box. And this box, I'm going to make like this. So that I've got 3 here and what, 2 down the top. So that up here, I'm going to put 2, 34, and 27. All right, now in each box, I'm going to put a diagonal. So now I'm going to ask, has anyone ever seen this before? Okay, I think. All right, now here we go. All I have to do now is go through here and find all these little individual products. 2 times 4 is what? 8. Now 8, and then significant digit here. 7 times 4 is 28. 2 times 3 is 6. 2 times 2 is 4. 7 times 3 is 21. 7 times 2 is what? Notice how everything has got a place. What I'm going to do, still, because the next step is the what? If we were doing it the traditional way, we'd be adding, right? So that's not going to change. But what I'm adding is along these diagonals. So that's how everything keeps lined up. So this first one's easy. It's 8. I'm going to put the sum here. 8 plus 2 is 10. Plus 1 is what, 11? Carry the 1 to the next diagonal. 1 plus 6 is 7, plus 2 is 9, plus 4 is what, 13. Carry the 1. And then 1 plus 4, 1 plus 0 plus 4 plus 1 is what, 6. Now you can, you know, that's 0. It's not significant. 6, 3, 1, what, 8. This is called the lattice. Again, I was referring back in 1800, students would have these things that were called Napier's rods, or also Napier's bones. And they would have these numbers, and they would have these strips of this. Wish I had a set of them. I don't. But then they would actually take this and then lay these like this, and then just, so they were good. And that's, that was kind of their calculator. So, I am not logged in. I did not log into my math lab. I'm going to do that here in a minute. I do have homework on my math lab. Because I'm wanting to say 6 problems total that covers these 3 methods. Okay, and so that's what I'm going to assign for new homework for Monday. So if you want to turn in your work for today, you may, and I'll take it. If you want to wait till Monday, that's fine too, to email it to me. And again, I don't know why I just never thought about, saying, I assume my account should be Chris Cunningham. I know I have one student that went out, and that's what made me think of it, from another class, Math 120 class, and she subscribed to the account, but it's all public, so, there's no, right? So, but I still will send the links that I have. All right, you guys good? So,